Hello and welcome to Dunia's Alchemy. This is the first part of a series on organic chemistry. The video breakdown is going to be on hydrocarbons, alkanes, properties of short and long hydrocarbons, and also combustion along with how to solve its equations. So let's begin. So the first thing we're going to look at is what exactly is a hydrocarbon. The word hydro in hydrocarbon comes from hydrogen, and carbon, as you guessed it, is carbon. So essentially it's a compound containing hydrogen and carbon atoms only. So C8H18 means 8 carbons and 18 hydrogens. That qualifies as a hydrocarbon. But if you see a molecule like this, where there are oxygens, that is not a hydrocarbon. So we're now going to go straight into our first type of hydrocarbon, and they are called alkanes. The first thing you need to know about alkanes are they're part of a homologous series, and the word homo here is same. That is basically a family of compounds that react in a similar way, and they have the same functional group. Secondly, alkanes are hydrocarbons that are saturated. So S for saturated, S for single. That means they have carbon-carbon single bonds only. They have a general formula of CnH2n plus 2. You must know the names of the first four along with their structure. So let's have a look. The first alkane with one carbon is called methane. I've given you the displayed formula first, along with the name, and then the actual molecular formula. If you add up all the carbons and hydrogens, that's what your formula would be. Secondly, with 2 carbons, it's called ethane. Again, add up your carbons and hydrogens and you end up with C2H6. Your next hydrocarbon is made up of 3 carbons. This is called propane, and again, if you calculate your number of carbons and hydrogens, you're going to end up with C3H8. The last one you need to know is butane. It's made up of 4 carbons and 10 hydrogens. They all follow the general formula that we saw earlier, highlighted in yellow, CnH2n plus 2. We're now going to look at some keywords. These are really important for you to know for your exam, and they show the examiner that you know exactly what you're talking about. So let's begin. The first one is called volatile, how easily it turns into a gas. An example could be perfume. The second one is viscous, and that essentially means how gloopy something is. So honey is more viscous than water. Thirdly, the word flammable, and that means how easily it ignites and catches fire. Fourth is your boiling point. It's the temperature at which a liquid turns into a gas. Although all hydrocarbons are made up of hydrogen and carbon, they're not all the same. Short hydrocarbons are very different from long ones. An example of a short hydrocarbon is propane, which we saw earlier, C3H8, and an example of a longer chain is C70H142, molecule that you see below. Side note, this is not the longest hydrocarbon, just an example of a longer hydrocarbon. So let's look at property changes as hydrocarbons get longer. The 2 factors we saw earlier that decrease are volatility and flammability, but 2 things that would increase is viscosity and boiling point. We're now going to look at what combustion is and the 2 types of combustion. Firstly, combustion is the burning in the presence of oxygen. There are 2 types of combustion: complete combustion, and you guessed it, incomplete combustion. Complete combustion uses plenty of oxygen, and the products that you make are carbon dioxide and water. Incomplete combustion is done in limited supply of oxygen, and the products are carbon monoxide or carbon and water. So why is it that in one we make carbon dioxide, whereas the other one we make carbon monoxide or even just carbon? It goes back to the first point. Complete combustion uses plenty of oxygen, so that means you have enough oxygen for carbon to be attached to 2 other oxygen atoms, making CO2. However, in incomplete combustion, since there's a limited supply, each carbon can only actually bond with 1 other oxygen and sometimes none. And that's how you end up with either carbon monoxide or even just carbon. Right, I've seen a lot of students struggling with balancing combustion equations. About to make it really simple for you. Now, I know you're all geniuses watching this. Look at this pink box in the corner over here. I'm going to explain something. When you have a big 2 at the front, it essentially goes for everything that comes after it. So the 2 multiplies the carbon along with the oxygen. However, when you have a small 2 hanging off the end of an element, it only goes for the element directly before it. This small 2 only influences the oxygen. So if I was to try and keep count of everything, I would have 2 carbons and 2 times 2 oxygen atoms, so therefore 4. Let's go straight into balancing the equation. First thing you need to do is make a list of our elements: carbon, hydrogen, and oxygen. There is 1 carbon in methane, there are 4 hydrogens, and there are 2 oxygens on the reactant side. Let's look at on the product side everything after the arrow. We have 1 carbon, 2 hydrogens, and 2 plus 1 more oxygen from water, so 3 oxygens. First thing I do is I put a 2 in front of my water. That way we now get 4 hydrogens and both my carbons and hydrogens are balanced. Then we're going to keep account of my oxygen. Remember, if I put a big 2 in front of my water, it impacts not only the hydrogen but the oxygen as well. So now I have 4 oxygen atoms, and therefore all I need to do on the other side is add a 2. Let's try the next one. Ethane plus oxygen gives me carbon dioxide and water. We're going to list our elements out underneath and keep a score of everything that we have. We've got 2 carbons, 6 hydrogens, 2 oxygens, 1 carbon, 2 hydrogens, and then 2 plus 1 more on the other side, 3 oxygens. First thing we do is our carbons are out of balance, so I'm immediately going to put a 2 in front of the carbon dioxide. Now we have 2 carbons. Next is our hydrogen count. So we have 6 hydrogens on one side and only 2 on the other side. So I'm going to go ahead and add a 3. Lastly, we're going to look at our oxygen count. So that is a total of 7. So all you need to do is do 7 divided by 2 and put that number in front of oxygen, which is 3.5. Yes, you are allowed decimals, but if it makes you uncomfortable, feel free to multiply the whole thing by 2 since they do accept multiples. So we're going to apply the same thing we did earlier with propane and butane. Propane is 3 carbons and 8 hydrogens. So as we start to list it, make sure that you've got 3 carbons on the other side. And then immediately I'm going to balance out my hydrogens and put 4 on the other side. I'm going to count the number of oxygens on the product side. So I've got 6 oxygens along with 4 oxygen atoms in water. That gives us a total of 10. So now what I do on the other side is put a 5 in because 5 times 2 gives me 10. Let's do the last one, which is butane. Carbon is 4 in butane, so I'm going to put a big 4 in front of the carbon dioxide. There's 10 hydrogens, so I'm going to go straight ahead and put a 5 in front of the water. There is 8 in carbon dioxide, and there is 5 oxygens in water. That gives me a total of 13. So I'd simply divide that by 2 and add that in front of the oxygen, because 6.5 times 2 would give me 13. Here's a little fact to take with you from this video. The rest of the alkanes from C5 to C10 follow the names of shapes. So if you know your shapes, you already know the name of the alkane with the same number of carbons. So let's have a look. Pentagon is a 5-sided shape, so C5 is called pentane. Hexagon is a 6-sided shape, so C6 is called hexane. Heptagon is a 7-sided shape, so C7 is called heptane. Octagon is an 8-sided shape, so C8 is called octane. Nonagon is a 9-sided shape, so C9 is called nonane. And decagon is a 10-sided shape, so C10 is called decane. Gon is the Greek word here for angle. We're not talking about Gon himself. That is our video complete. Let's look at the breakdown that we saw at the beginning. We've officially completed hydrocarbons. We've also done alkanes. We've looked at properties of short and long hydrocarbons. We've looked at combustion and its equations, along with a fun little fact at the end. Thank you for watching, and make sure you do the 3-2-1. Share it with 3 others. 2 clicks, subscribe and like, and finally 1 comment. Have a great one.